the most important machining companies in our city. And I'm with my college peers, Lisbeth Garza, Astrid Carrizales, María Luisa Ornelas, and I am Melissa Ornelas.
We're visiting Tecnologías Alternativas del Noroeste, which is a Mexican company whose business is to do parts made of metal mechanical structures.
This company uses a lot of machining processes, but today we're going to focus in the two primary machining processes of manufacturing, that is lathe and milling.
Fun fact, throughout the 21st century, Mexico's industry manufacturing has accounted between 15 and 18% of the industry in a total basis. Come with me.
Sí, la empresa Tecnologías Alternativas del Noreste se crea a finales del 2013, inicialmente vendiendo productos principalmente a gobierno del estado. Era nuestro cliente principal, ¿no? Y le vendíamos pues temas de papelería, algún otro servicio, sistemas. Y hasta 2015 fue que empezamos a operar con las maquiladoras. Entonces ya brindarles soluciones industriales, ¿no? Basadas en el uso de máquinas y herramientas, como todas las personas.
Si pueden pensar, pues Sagitario no hay quien haga esto. Entonces, generar tantos empleos y voy a generar una economía alrededor de mi proceso. Voy a necesitar quien me venga a dar mantenimiento en los aires, quien me ponga pintura impermeabilice el techo, demás, ¿no? En este caso nosotros vimos el nicho de mercado de no hay quien haga máquinas. Y es una industria completa. Si tú te vas a la frontera, hay mucha oferta y demanda.
BMW es cliente de nosotros y nos introdujimos a venderles porque alguien que trabajaba en Aptiv empezó a trabajar en BMW y dijo, yo conozco la Ciudad de Terra, que no se lo puede hacer. Y le ganamos a los proveedores de San Luis Potosí. Sí, o sea, fuimos a competir con la gente de San Luis Potosí y allá está desarrollado de competencia. Y pues algo hicimos bien.
Ya sea que el cliente nos haga llegar el plano de la necesidad, o si no, nosotros vamos ahí a sitio, entramos a la línea de producción, vemos la necesidad, vemos si ya tienen algo hecho y ya lo reproducimos o lo mejoramos, hacemos una propuesta haciendo uso del software de CAD. Entonces aquí
por ejemplo, ahí ustedes reciben la pieza y a partir de esa pieza tenemos un diseñador que...
Es correcto, o sea, podemos hacer ingeniería inversa, de que nos diga el cliente, ¿sabes qué? No tengo un plano, pero tengo la pieza física y necesito que haga esta función. Entonces ya con eso podemos nosotros estimar qué tolerancias tener, qué materiales aplicar, porque a veces no tienen ni idea de eso. Entonces el plano, la información que tiene, además de la dimensionalidad que debe de dar la pieza para la hora de operar las máquinas, también incluye qué material es y algunas instrucciones extras, ¿no? Por ejemplo, vas a hacer una rosca para este tornillo, pero le tienes que hacer una cajita para que se esconda la cabeza del tornillo de tal profundidad. Este agujero no, este agujero tiene que ser completamente pasado. Estas dimensiones tienen una tolerancia de más o menos tantas milésimas de pulgada. Acá no, acá sí tienes que tener mucha precisión. Pues las tolerancias son menores, ¿verdad? Toda esa información pues, y a veces incluimos la visualización 3D para que el operador pues, tenga una mejor visualización de lo que está haciendo. Entonces, si gustan, ahorita les muestro las máquinas y les muestro algunos de los productos y les muestro el flujo de trabajo.
Okay, first let's start talking about milling. Milling is the most common form of machining, a machine removal process which can create a variety of forms or features on a part by cutting away the wanted material.
Now let's begin talking about the parts of this machine. First, we have the x-axis, the y-axis, and the z-axis. In this part, we have the logs of the table. That means that the table won't move if we try to move it, as you may see in this. Now, if we take them down, like to the other side, and here too, we can see how the machine moves now to one side and to the other side. And also in here, it goes to the front side and behind. And with the z-axis, we can see how the machine goes up and down. In this part, we can see the digital indicators that give us a number where the machine is when we move the handles. Now, if we go to the upper side, we can see the power switch, the brakes, and the motor. And here we can see the refrigerator and well.
Now let's talk about the protective equipment. When working with a milling machine, the most important item is safety glasses. However, depending on the conditions, for example, if we have to work outdoors, the conditions will determine if we need to wear a helmet. Also, the material is very important since we are working with a material that has a lot of dust. It will be necessary to wear a face mask. Another important thing is that we should always have our hair tied up and the accessories are not allowed.
Okay, now one of the advantages of using this machine is that it can give you the opportunity to make accurate cuts and you can customize the piece that you want to create. On the other side, one of the disadvantages, as you can see here, is that produce a lot of material waste and the time that is required to customize or make a piece is considerable.
Milling is ideal for asymmetrical pieces with many features, such as holes, slots, or pockets. Parts fabricated with milling are used in limited quantities. Another application of milling is the fabrication of tooling for other processes, like three-dimensional mold. Also, it is used as a secondary process to add or refine features to a part whose basic shape has already been formed. Metals such as aluminum, alloy steel, carbon steel, and stainless steel are the most common materials for milling processes.
Now let's begin talking about the lathe. The lathe is a cutting tool which helps us to reduce our diameter from a workpiece to obtain our desired dimension.
Well, now we have our lathe here. Some main parts are the tailstock, which is the one that we can fix in the case that our material is long or short. It's depending on the size of the material. We can see here also we can move it backwards and forwards. With the lock we can fix this and this is moving anymore. Also we can move this as the same way, but we have a lock too and now we can move it anymore. We have here the tool pull, the spindle, which is gonna make the rotation of our material and it's gonna do kind of all the work here. We have here a piece and the tool, the cutting tool, which is gonna make the cutting. We have our bed and this is our headstock. If you come with me here, if you get a little closer, we have the spindle or linear screw. And also here we have some handles which is gonna control the RPM of the spindle. As you can see here, we have different meaning for each of the spinning. And these three are the ones that do almost count of the year.
Now let's talk about the protective equipment for the lathe. It's very similar to a milling machine. In this case, the most important thing, remember, is the safety glasses. However, depending on the conditions, we will need to wear a safety helmet. It's important to mention that to manipulate and operate a lathe, it's not necessarily mandatory to wear gloves. However, if we are going to touch chips or something like that, in that case it will be necessary. The last thing is that our hair should always be tied up and the accessories are not allowed in this area.
Now, one of the advantages of using this machine is that it can give you the opportunity to make precise cuts and
it requires few operators to machine a piece. On the other side, one of the disadvantages of using this machine is that it's quite more expensive than others, and that's all.
Lathes are normally used for machine parts, where the material part is clamped and rotated, whereas the cutting tool is stationary mounted for outer diameter and inner diameter operations. As an example, shafts and pipes. They are ideal for parts that have the same symmetry around the annexes that could be chucked out. As an example, radially clamped in the spindle. Anything from metals like aluminum, steel, and titanium to plastics, wax, and delrin can be used on a lathe. The different materials used must be within the size limitations of the machine. The material used also affects aspects of manufacturing, like the speed the lathe rotates at.
Machines are valuable and durable equipment used to complete various machining operations on the workpiece. The most common problems are often used by user error and poor maintenance. One of these problems are improper cutting tool, which make the poor surface finish on the part, and there may be some errors due to the programming, and if the machines are not being cleaned and lubricated, dirt and debris will be built up on the equipment and affect the location and clamping of parts. The material blank or workpiece can't be fixed firmly by the chuck or the fixture shift or vibrate during the manufacturing process. This may cause the wrong location and the processing is not smooth and the pieces drops and even an accident or other problems.
Quiero aprovechar este mes y medio porque ya
¿Ves? Ya lo estaba diciendo